In this session, we'll discuss what is midterm, what is maxterm, and how to write down the Boolean expression by using midterm and maxterm. So here, to discuss about the midterms and maxterms, we are considering three Boolean variables. And we had written one table to denote these midterms and maxterms. And always the midterms are represented by using small m and the maxterms are represented by using capital M. So since we had considered the three variables and we will get 2 power 3, that is 8 combinations. And the 8 combinations are 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. And always the midterms represents the product terms and the maxterms represents the sum terms. We need to write down the product term such as the product term value will be equals to 1. So to get the 1, we should represent or we should consider these variable values either directly or complement variables. So direct variable represents its direct value. Complement variable represents its complemented variable value. So since if we consider the first combination, that is 0, 0, 0. So how to get the product term by using 3 zeros? So compulsory the product term output value must be equals to 1. So by using these 3 zeros, how can we get the 1 value in the product term? So then we know the formula such as for the n term or for the product term, all the input must be equals to 1. So since the x direct variable value is 0 in this combination, so to make it as 1, we should take the complement variable for this x. Similarly, for the y, we should take the complement, and for the z, we should take the complement. So then the product term for this combination is equals to x dash, y dash, z dash. And this x dash, y dash, z dash midterm can be represented as M0. So this 0 denotes the decimal equivalent number of this combination. Similarly, if we take the combination of 0, 0, 1, the product term will be equals to x bar, y bar, and z. And it can be denoted as M1. And the product term for the combination 0, 1, 0 is x dash, y, z dash. So wherever we have zeros, we should take the complement values, and wherever we have ones, we should take the direct variable values to form the midterms. So similarly for the 0, 1, 1, it can be x dash, y, z. For 1, 0, 0, it is x, y dash, z dash. And for this combination, it is x, y dash, z. And for this, x, y, z dash. And for these terms, x, y, z. And the midterms can be represented by using the small m, and these numbers will represent the decimal equivalent values for this combination. 0, 0 represents 0, 0, 0, 1 represents 1, 0, 1, 0 represents 2, 0, 1, 1 represents 3, 1, 0, 0 represents 4, 1, 0, 1 represents 5, 1, 1, 0 represents 6, and 1, 1, 1 represents 7. So now we'll come for the max terms. Max terms are always called it as sum terms or terms, right? And always the output of the R term or the output of the sum term must be equals to 0. So we should consider the variable such that whereas the sum term output will be equals to 0. And we know that to get the zeros for the R term, all the input values must be equals to zeros, right? So if we have 0 in the variable, we have to take the direct variable. If you have 1, we have to take the complement form of that particular variable. So for the 0, 0 combination, the max term would be x plus y plus z. And it can be denoted by using capital letters M naught. And this 0 represents again the decimal equivalent of this particular variable. So for the combination 0, 0, 1, we can return the maxterm such as x plus y plus z dash. So when 0 is there, we should take the direct variable. When 1 is there, we should take the complement variable. So based on that, we can write down the maxterm for the combination 0, 1, 0 like x plus y bar plus z. Next, x plus y bar plus z bar. For the combination of 1, 0, 0, the maxterm is x bar y z. That is x bar plus y plus z. And for the 1, 0, 1 combination, x bar plus y plus z bar. For the 1, 1, 0, x bar y bar plus z. For the 1, 1, 1, x bar plus y bar plus z bar. And the maxterms can be denoted by using capital letters, and these numbers represent decimal equivalent value. So this is the way how to write down the minterms and maxterms for the three variables. And by using the same concept, we can write down the minterms and maxterms for any combinations of the variables. Once we know the minterms and maxterms, the Boolean expressions can be represented in two ways. One is SOP form, or we can say that sum of product forms, and another one is POS, that is product of sums. So first we'll see that what do you mean by SOP, sum of products. Let the expression or the function f of x comma y comma z is equals to x dash y dash z dash plus x y dash z plus x y z dash plus x y z. How to write this particular Boolean function expression in terms of minterms, right? So here, if you remember the table, directly you can refer that what does the minterm it represents, or you can write down these ones and zeros. Based on that, even you can write down these minterms, right? So minterms are nothing but the product terms where the output value can be equals to 1. So that if it is a complement form, it denotes 0. If it is a direct form, it denotes 1. So x dash, y dash, z dash represents the values as 0, 0, 0. So which represents m naught. Similarly, this particular term represents 1, 0, 1, which represents m5. Similarly, 1, 1, 0, which represents 6. 1, 1, 1, which represents the minterm of m7. So we can write down the expression such as m0 plus m5 plus m6 plus m7. So here the expression in the form of sum of product terms. And in short, we can refer it as SOP. And overall, this function can be written as f of x comma y comma z is equals to sigma of 0, 5, 6, 7. Whereas this particular numbers represents the minterms and sigma represents that it is a sum of product terms. And for this SOP, even we can determine the complement form. We will find the complement form such that whatever the numbers or whatever the minterms which are not presented in the direct function, those numbers or the minterms can be included in the complement of function f. So here f of xyz contains the minterms as 0, 5, 6, 7. So the complement of f function contains the minterms of 3, 1, 2, 4 or 1, 2, 3. So 1, 2, 3, 4 will not be there with this particular function. So now we'll see that what is POS. POS refers to the product of sums. So we are getting product term, some terms are producted. So the expression can be written like this. And this particular expression can be written in the max terms by using its terms. So while writing the max terms, you know that the sum of the product term, the sum of the R term must be equals to 0. So direct variable represents 0 and the complemented variable represents 1. So this value is 0 plus 0 plus 0. So which represents m naught. 0, 0, 1, which represents m1. 0, 1, 0, which represents m2. 1, 0, 0, which represents m3. And to represent this POS, we have to use the symbol as pi. Pi of 0, 1, 2, 4. So these numbers represents the max terms. Similar to the previous concepts, here the complement of this function can be written or can be determined in the same way. Whatever the max terms are not presented in this particular function, those max terms can be presented in the complement function. So here 0, 1, 2 are there. So 3 is not there. So the 3 can be written in the complement form. 5, 6, 7 are not presented here. So it can be written in complement form. So f dash of x, y, z is equals to pi of 3, 5, 6, 7. We'll see one gate problem related to the minterms and maxterms. The minterm expansion of f of p, q, r is pq plus qr plus pr bar is, and the expression is written in minterms in the option. So we should expand this particular function in terms of minterms. So to write down the function in terms of minterms, we have to find out the missing variable. So here in the first term, the r is missed, and for this r, we should write down both the combinations, that is r and r bar. So for the cube pq, it is very clear that the p value is equals to 1 and q value is equals to 1, and r variable is missing. So for the r, you should write down or you should consider both the values, that is 0 and 1. So here 110 represents the minterm of 6, 111 represents the minterm of 7. Similarly, QR bar. So here PQR bar. So P is missing. So for the P, you should write down 0 and 1. For the QR bar, Q is equals to 1 and R bar is equals to 0. So the minterms are 2 and 6. Similarly, for the third term, P, R bar, and Q is missing. For the Q, you should take both the values. So the combinations are 1, 0, 0, 1, 1, 0. So which represents the minterm as 4 and so the answer will be M2 plus M4 plus M6 plus M7. So which represents the option. So in the next class, we'll see K maths or the corner maths using this minterms and maxterm. Thanks for listening to us.